Hello solar energy fans, and welcome to the design stage of the PV system. Now we are going to learn the effective steps to get the best design, and let's go. First of all, we have to estimate the energy consumption, AC power and the peak sun hours. Then we will sizing the DC side and number of PV modules. We will calculate the azimuth and tilt angle. We will also sizing the inverter and calculate the system area, wire sizing and the breakers, and energy yield shading analysis with SketchUp and PV system. These steps will give you a full design for the solar energy system. Energy consumption and peak sun hours. Energy consumption can be calculated from electricity bill in kilowatts hour. Peak sun hour can be calculated from PV Watts website for any location in the world. Let's see how. Go to the PV Watts calculator, enter your location by latitude and longitude or by the name. For example, Egypt. Go to the result, and this is the peak sun hours that we need. After that, we will estimate the average energy consumption, and we need the average peak sun hour for certain location as we see. So we need the energy consumption and the peak sun hour. We can find the energy consumption from the electricity bill, and we can find the peak sun hour from the PV Watt calculator. Example, you can get these values of consumption for a house from the electricity company website in your country. Sum all the values and we will get 659.2 kilowatt hour. Estimate the average for the total summation of the values and we will get 549.33 kilowatt. So we sum all values and estimate the average of energy consumption. Then assume this location to get the peak sun hour from PV Watt, and the average peak sun hour from PV Watts for this site is 5.66 for the day. Now we need the peak sun hour for the whole month and multiply 5.66, which is the peak sun hours for one day, by 28 as a safety factor, and we will get 158.5. So now we will use this data to sizing the DC side. DC need can be calculated in simple equation, which is average energy consumption, not the total, over the average week sun hour for 1 month. So if we calculate the DC load in last example, we will get 54.9, which is the average energy consumption, over 158.5, which is the peak sun hours for the month, and we will get 3.46 kilowatt peak DC power. So number of PV modules equals system size over PV watts. If we choose JinkoSolar, for example, 305 watt PV panel, we will get the number of PV modules 3.46 kilowatt peak over 0.305 kilowatt peak, not 305 kilowatt peak, because we should to use the same units to get the right result. So we get 11.35 panels and we round it to 12. Okay, so we estimate the average energy consumption and get the peak sun hour for a month, and then divide the energy consumption average over the peak sun hour to get the DC need, and the number of PV modules equal to the system size over the PV watts. Okay, the angles. Azimuth angle, as I said, here in Jordan we are in the northern part of the land, so we will face the angle to the south, and if we in the southern part of the land, we will face the angle to the north. So it's easy. The tilt angle, we can calculate the optimum tilt angle for any system by latitude multiplied by 0.98 minus 2.3. Latitude of Jordan equal 30.585, so the tilt angle by this equation equal 27.6 degree. This is the PV module data sheet and we will use it in our calculation.